All right, this is going to be a video explanation of your review. I'm going to go over a couple in each section. Just make sure you have the right idea to help you complete it. This first part is important because it tells you what concepts are going to be on the test, which are some keywords, vocabulary, things you need to know. Okay, so I would say make sure you can know each of these, know the facts, maybe memorize. Oops, I spelled that wrong, sorry. So I'm just going to kind of go over each little section here and just tell you where you need to go to study. Okay, so getting equation in standard form. This is the key information. Standard form. Standard form is when the equation is equal to 0 and it's in this form: a x squared plus bx plus c. Okay, we need it to be equal to 0 so that if I need to use my calculator, I can substitute the y for the 0 and plug it in. All right. Now, where this information was covered, it was on our green little graphic organizer, how to use the solve and graphing and analyze a quadratic function. So it was on this green one right here. Talked about standard form then. And get back to the review. And on that green, and also in our key parts, features to the parabola, you need to know that if it's not equal to 0, make it equal to 0. Basically solve the equation for 0. Eliminate the terms to get it to equal to 0. And then the parts to the parabola, this is important. You need to know your axis of symmetry, your vertex, your maximum or minimum, your it's supposed to be x-intercepts, roots, and solutions. So that is all off the key features of a parabola. This was our very first Edpuzzle, or not first Edpuzzle, but it's our Edpuzzle for this unit. So make sure you know each key part on a graph. Most likely I'm going to give you the graph. I'm not going to ask you to recite the definition. I'm going to ask you to locate it and analyze it off of a graph. So we need to know that. And then we need to know that solutions for x are basically your zeros, your roots, your x-intercepts of the parabola. So we want to really focus on x-intercept. And the other thing is not on here that I probably should have stated, but you're going to be able to still answer it because you're going to have a graphing calculator, is make sure we understand the vertex form. And the vertex form is when we have y equals a parentheses x minus h close parentheses squared plus k. So there's 3 sets of notes. There's our green, this one. There's our key features to a parabola, which was this. And our third set of notes is our vertex form, graphing of vertex form, and transformations. That's kind of what we've been working on recently. All right, so in this first section, it just wants you to identify the key features on a parabola when given a graph or given a description. So this is your word bank. Oops. And this is for our first problems. I think it's 1 through 8. Yeah, 1 through 8. Oops, sorry. Okay, 1 through 8. So once we use one of these words to answer the question, we will not repeat it. We can scratch it off. So first one just starts off, what is our standard form of a quadratic equation? Well, that is our ax squared plus bx plus c. That's right here. The shape of a quadratic equation is called, that's a parabola. That's the U shape. U shape. All right, so we use that one. Now, this next two, we need to identify off just a little picture. So number 3 is pointing to this red vertical line here. And that we should know and recognize is our axis of symmetry. Actually, we tend to do this abbreviation. I'll write it out here. Axis of symmetry. Okay. Now number 4 is pointing to this little bullet here. It's pointing to that point right there. And that is called the vertex. Hopefully remember that. Okay, it's our turning point. It's where the max or the min is on the parabola. And that's what we're going to get into here. It says when the vertex is the highest point in the graph, we call that a maximum. When it's the lowest point, like this one right here, that's the lowest point, we call that a minimum. Now, our solutions to get the answer to a quadratic, we find those solutions on the x-intercept. Okay, it is the x-intercept. And solutions to a quadratic are called zeros, and they are also called roots. So it's just another name, and that was here on our key features to a parabola right here. X-intercepts are also called roots, zeros, and solutions. They can be represented with a bracket or your order pair. Okay. So now we're going to get you to analyze graphs. So I'm going to give you the graph. So analyze this quadratic. Then I want you to determine if the quadratic function has 2 real roots. Basically, that's saying 2 x-intercepts, 1 real root. That means 1 x-intercept, or no real root. So that means no intercept. And I probably should abbreviate that. No intercept. Okay, so you have to focus on the x-axis, and I don't know if the graph or the copy is not as great for you. So like this is our x-axis here, this is the x-axis, and this is the x-axis. So what we wanted you to see is, could you read the number of zeros off the graph by seeing if it touches the x-axis, and then determine what the zero is. So here, there's only 1 root. That root is at this vertex, this order pair, where it is at 3, 0. So the 0 is your x-intercept. So you just put the x value. It's x equals 3. All right. Now on 10, notice that this parabola does not touch my yellow x-axis. So we can say there's 0 roots. And if there's 0 roots, we say no solution or no zeros. Okay. And then hopefully we see on 11, it touches here and here. So there's 2 roots. And the values of those roots are when x equals, I'm going to do the bracket. This is a -2 right there. And that is at 0. Oops, that was like an 8, sorry, at 0. Okay. So that's all we're doing, is just analyzing the graph. So now we're just taking a little step further. Now we're asking to find the different parts to the parabola, the key features. So I give you the parabola here. This is my blue U shape here. Your axis of symmetry, I would always identify our vertex because our axis of symmetry goes through that point. It's that vertical line. And that, by showing that vertical line, I can, hold on, let's see if I can get rid of this. Yeah, there's got to be something going on with this. Okay, sorry. Why is it saying plus asterisk? All right. So I can see where this vertical line touches the x-axis, and it touches right here. So this would be x equals 3. The vertex is the actual order pair of this point right here, and that would be 3, -2. And I can physically see this is the lowest point of my parabola, so this is a minimum. Our domain is always all real numbers, and our range corresponds with that min. So because it's a min here, this graph is pointing up and keeps going, going, going. Up is greater than. So y is greater than or equal to the y value, which was at -2. And our roots are where the graph, the parabola, touches the x-axis. So it touches here and here. So the roots are x equals, I'm going to do a little bracket, 2, 4. Okay. So you will need to basically understand those parts to complete this problem, this graph, okay? Again, our x-axis is right here. I'm just going to highlight to help you. And the y-axis is right here. Now, on number 14, you're going to need a graphing calculator, and that requires either use the Calculate 84 app on your phone or the Desmos calculator. So here, we would have to type this in. So you have to go to y equals. Let me clear this out. You're going to type in the equation so we can see the shape of our parabola, and so we can see our point. So y equals, we have parentheses, then x minus 5, close the parentheses, square, then plus 3. All right, so we're going to hit graph to see the shape. There it is, right there. And then I want to hit second graph to see my table, because I want to find values, the middle of the graph, to see where the values repeat. So like, I know they're getting smaller. And then right here, I can see the repeat happened here. See the 5, 3, and then it went 4, 7, 12, and then it's going 4, 7. If I go down even further, I can see those numbers are repeating. So they're repeating. The midway helps me get my vertex. And this helps me graph it as well. So I can see that my vertex was at 5, 3. I think that's what it was. Yeah, 5, 3. Let's put that up here. We're going to go to the right 5, up 3, 1, 2, 3. There's just a point. And then this is where our axis of symmetry will be. This is our line of reflection. So it's x equals the 5. So I know after 3, the pattern and the points in this table. So 6, 4, and then 7, 7. So just remember, these points get reflected. So if I go 6, 4, and 7, 7, all I need is 3 points, because if this point is 1 unit to the right from the axis of symmetry, then I will count 1 to the left. There's the reflection point. If it's 2 units to the right, then we count 2 units to the left. There's its reflection point. So now I can sketch a line through our points here to create the parabola. And now we can do each part. So let's just see if we can figure out the parts. The domain here should be all real numbers. The range deals with the vertex that we have, which is here. This is our vertex, and our vertex represents a minimum. So it's y is greater than or equal to that minimum. That minimum is 3. It's the y value. And since this parabola does not touch the the x-axis, sorry. This parabola does not touch here. I'm going to do that in yellow, sorry. Just like the previous one. So if it doesn't touch the x-axis, we say no solution, no roots. All right, no real solution. We'll talk about that later. All right. So from here, now we're asking to kind of put it all together. Now we're asking do it kind of what we were doing earlier, was type in the equation into the calculator. These equations going to be in vertex form. Remember, that's the form we have: a parentheses x minus h close the parentheses plus k. And when I'm trying to find my vertex, the vertex always represents the h and k in that form. So on this first example, I see the h. H is inside the parentheses. If this is minus 4, then the h is positive 4. And there's no k over here. There's no adding or subtracting outside the parentheses, so that would be 0. So that's my vertex 4, 0. And we're going to plot that. So we're going to go to the right 4 and plot that point right there on the x-axis. Remember, the axis symmetry goes through that point. It's the halfway, split in half. So this means x equals 4 for that vertical line. So we're going to get this in the calculator so we can fill in our table. And the thing we have to remember on a problem like this, okay, so y equals 1/3, that's alpha. Y equals, to get my fraction box, a 1 on the top, 3 on the bottom, arrow to the right to open up that parentheses, x minus 4, close the parentheses, square it, and then when we go to graph, yep, we see it. That's kind of what I have as where my vertex is. Yep. When we go to the table, what we want to remember is when we're plotting points, we can't plot fractions. We need exact points, whole numbers. So we knew that the vertex is at 4, 0. And then if I look, the next whole point is at 1, 3. So in my table, 1, 3, and then if I go up some more, it's at negative 2, 12. So what I would want to put is 1, 3 here, and then negative 2, 12. And that's repeating on the other side. So I need to look on that table, and I'm going to have to scroll down. And there's 7, 3, and 10, 12. Okay, so we're going to go 7, 3. There's that 3 repeating, and 10, 12. All right, so we got the vertex. We're going to do 1, 3, so that's to the right 1 and up 3. 1, 2, 3. That's 1, 2, 3 away, so I can reflect it. There's that point. And then we have 7, 3. I don't think I'm going to see that's 4, 5, 6, 7, 3. I did that. And I can't get 10 because it's not big enough. But I have enough here to sketch the shape of my parabola. All I need is really 3 points. So there it is. And then we're comparing this on our transformation to the parent function. So we got the axis of symmetry, vertex, domain is all real numbers. Our range correlates with our max or min. This is a minimum. So it's y is greater than or equal to 0. It's always the y value. Now the transformation. The transformation is identify the transformation of the equation from the parent function. Got to remember the parent function is when we get y equals x squared. So it's just our original parabola, and I can kind of just show it on here. That is x squared. And so this is the red here is the parent. And if you look, my graph basically still moving up. So it didn't do any reflecting. It's still opening up. So there's not really an A as for a negative sign. But the vertex on the red, the original 0, moved to the right 4. And if you look, the shape of the parabola got wider. So to help you with this, that's why we want to focus on this note sheet. So we start with the A. There's no sign change. There's no negative. But it's either narrow, a stretch, or wide, a compress. It's a stretch when the absolute value of the A, the number in front of the parentheses, or the x squared, is greater than 1. And here gets wider, compressed, when it's between 0 and 1. 0 and 1 is when basically we're going to have fractions here. So we want to do each part to describe the transformation. So transformation is that the graph got wider. So that means it was compressed wider. So that's the A. Then it moved to the right, so that has to do with the H here. So the A here is just 1/3. That's how I knew, since that's a fraction, that's why I got wider. So now I do the H, that's the horizontal shift. So graph compressed wider, and we have a horizontal, I'm just going to abbreviate that, shift to the right. So I'm just going to put R for right, and it moved over 1, 2, 3, 4 units, whatever numbers inside the parentheses. So I'm going to say R4, and there is no K, so there's no vertical shift. So that's all we have. So that's what we're going to ask you to do here on this section. Now, you need a calculator for this, so try to use the one either online or in class to get this done. And then our last section is, now we want you to write the equation based on the description. We're writing the equation in this form here, y equals a parentheses x minus h close parentheses squared plus k. So we're checking to see if we have a h, or a k. Now, if it says on number 19, translate it 3 units to the left, that's your h, okay? And if it goes to the left, if you go back to your notes, right here, it's a plus when you shift to the left. So inside the parentheses, we have to have a plus sign. So here, because it's only horizontal, okay, left 3, then all I need is just this part in my equation. So this would be y equals x plus 3 parentheses squared. That's it. Okay. Now on 20 here, we have translate 5 units down. If it's going down or up and down, that on our notes right here, vertical shift, up is plus, down is negative. That's our K. So this doesn't have a H or A, it just has a K. So that would be y equals, there's none of this, so x squared, then minus 5. So the goal here is to see, can you take the description and write the equation? Like on this next one, this last one I'll do with you, we have 2 units to the right, so that's a horizontal, to right, and we have 4 units up. That's a vertical, 4 up. So we have a H and we have a K. So no A. Didn't get wider or skinnier. So y equals, parentheses, x. If it's to the right, we have to do minus 2 squared. And then 4 units up, that's plus 4. So we're just trying to see, can you come up with the equation here? And then you have one little thing of a couple star-like problems. And like I said, we have an extra credit review to help you prepare. Definitely do that. Your tests, all tests moving forward, or assessments or checks or practices, will be online. So you got to get familiar with that for STAR. If you have questions, please come to tutorials. All right, thanks.